Hey students, welcome, and again we are here to do the revision of the second chapter, because you know that without revision there is no work going to be complete. So we will do revision properly so that the things we have studied till yet will be in our mind. Okay?
If we are given lemon juice and soap water in two different beakers, will we be able to list the difference between the two? Perhaps the list will begin with the different colors, appearance, and so on. But these are just properties that we can see. Are these the only differences? There are more. Lemon juice tastes very sour. Soap water tastes slightly bitter. Please don't try to taste it. Just trust me, it tastes slightly bitter. Is this a major difference between the two? Yes. Taste is an important parameter as it takes us to the chemical properties. Why does lemon juice taste sour? And why does soap water taste bitter? Any idea? The answer lies in their nature. Lemon juice is an acid while soap is a base. Do you know what an acid is and what a base is? Let's get to know these terms first and later get into the details. To begin with, we have acids. The moment we hear the term acid, something scary or something that would burn the surfaces is what pops up in our mind. Well, that's kind of true, because acids are known to create a burning effect of whatever comes in contact with them. They can erode the surfaces or burn the skin when they come in contact with it. That's how acids are. The term acid comes from the Latin word acidus, which means sour. Yes, so are all acids sour to taste? Yes, they are. The intensity of sourness may vary in different acids, but the overall taste of acids is always sour. The best examples of substances that contain acids include citrus fruits like orange, lemon, lime, and grapes. Now let's talk about the soap water. What nature does it have? It is basic in nature, which means soap is a base, or in other words, an alkali. What do we mean by this? For now, all we need to know is that the mild bitter tasting compound is called a base. Bases, when added to water, give foam and feel soapy when touched. Bases are exactly opposite to acids. The best examples of bases include baking soda, washing soda, quicklime, and many more. This was about acids and bases in general. Now, can you tell me what will happen if an acid and an alkali, as in a base, come together? Will the solution explode? Will it give an unexpected reaction? Or something else? Well, it is something that we already know. Imagine we mix a strong acid like hydrochloric acid with a strong base like sodium hydroxide. What will be the result then? The reaction yields sodium chloride and water. Sodium chloride is the common salt used by us. So, an acid with a base gives us salt and water. This is a generalized reaction. Salts are the product of reaction between an acid and a base. But now tell me one thing. How do we understand whether a compound is acidic or basic? Can we taste it every time? If we are given a solution of concentrated sulfuric acid, how are we supposed to know its nature? It's not possible to bear even a drop of it on your skin. So tasting the solution is just out of the question. So now, how do we say that this is an acidic solution? There has to be a way to figure it out. The solution has to undergo a few tests. The substance used to check whether the compound is acidic or basic is called an indicator. The indicators indicate by changing their colors. Indicators, when added with acids or bases, show a change in color. That is how it becomes convenient for us to find out whether the compound is acidic or basic. But what kind of substances are used as indicators? Next, we will look at the various indicators.
So students, next topic we will do the revision of indicators, including indicators like olfactory indicators. So go with those slides I have shown earlier, so that in the revision video you will study and you will understand better. Hope it will help you. Thank you. Bye bye. Take care of yourself.